In an ideal world, this experiment I'm running right here will work perfectly. I've got a battery connector, a Raspberry Pi, a GPS sensor, a VOC sensor, UV sensor, all for the purpose of getting location-based information. In this case, I'm really interested in tracking mostly the location aspect. This is my real-world test of this sensor so that I can begin mapping the chemical signatures of various other locations like stores to understand their VOC, or even local parks where maybe not all parks are created equal and the amount of exposure to different chemicals that our children are experiencing. And so before I go and spend hours in a hot park, I figured I should just road test this experiment while I go run a few errands. Interestingly, the only feedback I have that this sensor might be working is that there's a small light that runs every 10 seconds or so, which is on the duty cycle of my experiment. Now, I don't have a way to look at the output. I tried to hotspot to my phone and then remote in that way, but there's not quite enough signal where I'm located. So hopefully I will know if this works. If not, I will make the adjustments needed based on whatever the feedback I have. The data is being logged in a log file, so I already have all the necessary code, and I will show you that on the tutorial channel, but I'll do a high-level run through here. There are several different functions that are used to individually control the sensors. For instance, I have a sensor that will measure the VOC index by computing both the temperature and humidity to allow for some compensation as the VOC can be impacted by humidity. And then I have a separate function for getting the location data. I have a function for temperature and everything that's needed for this experiment, with the hopes of being able to then map more localized data over to different locations for understanding our world around us. I demonstrated in a previous video my ability to use a near IR sensor to go around different parks and measure those chemical signatures, and I really want to be able to combine all this data to paint a chemical map of the world. That blue chip on top is the environmental sensor I'm using, and that contains everything. The GPS signal I'm using is actually right behind here, hopefully with enough satellites. I wasn't able to confirm that before running, but I tested that separately, and when I had a clear view of the sky, it worked pretty well. It's a fairly inexpensive $14 sensor. I'll show you how I connected that in a separate video on my tutorials channel. To the extent that I can take it, I'm going to try to ride with the sunroof open to allow for more air exchange and hopefully faster turnover of the data. Interesting, it looks like they might be redoing some of the blacktop over here. So I'm not sure if I should expect elevated VOCs. Maybe they're still prepping for the job. Get away from the lab. What you doing, little buddy? Have slightly more signal, and it definitely appears like it is working. We'll review the data later, but you can see it's creating the logged file, which is what I'm looking for. So that dictionary output is going into a text file that we'll process later. You've got to love that LA traffic. There's almost nowhere you can go without traffic, particularly around this time of day. Just sort of part of the culture. I'm over the culture. That was the mountain range that was on fire a few months ago. Okay, the experiment's over. Let's take a look at the data. Okay, so I just finished my tutorial on the data analysis. So I'm going to switch over to this camera and tell you what I just found. Welcome back. So all of the data from this little computer was transferred to my Mac via an SSH protocol, where I've now moved the entire folder. Now I can do all of my data analysis on my Mac and not have to put more load on my Raspberry Pi, and I can just use that as the multi-sensor instrument. So the data analysis is fairly straightforward. We have latitude, longitude, UV raw, UV index, VOC, temperature, and humidity. And I'm going to read that in from my environmental test scripts, environmental_data.csv. Next, I'm going to compute a timestamp that I'm probably going to want to use in a future study but I'm still determining if this is going to work out. So a lot of this is just testing out the hardware, the connectivity, my ability to maintain connection with the satellites. I did notice that a few data points had dropped. So when this sensor drops, it actually returns a 0 for the latitude. As if I continue here, you can see there's a block of data where the latitude and longitude are 0. And so what I'm going to do is replace the 0 with a missing value, np.nan, and then I'm going to just interpolate those values using a linear interpolation. I'm going to do the same thing for VOC. So there's just times at the beginning of the experiment where the VOC sensor was still heating up. It had not quite equilibrated yet. And so I'm also going to interpolate those values early on and just recognize that this is just one of the trade-offs with such a small sensor and a common practice. So I'm going to create a scatter plot of my longitude and latitude data. I'm going to use the VOC index as my hue and then use the Veritas palette. When I run that, you can see that we have what looks like a reasonable plot where you can see my rough coordinates around as I drove around the city and the VOC index. Now, obviously, this data be much better represented on map, so let's do that next. If I make that same plot using the px.scatter map box, where I pass in the latitude as my lat, the longitude as my lon, and then I color with VOC index, you can see that we have a much more informative plot where we now have some context of the region that I was traveling throughout the city as I was running various errands like going to the Goodwill, running some errands in Pasadena, etc. And we can see how the VOC has changed across these different areas. Now, I'm sure part of it was the difference between my windows being up, my windows being down. Some of us spending some time in Pasadena. I did notice that the air index was a bit worse in that area. And then coming back in traffic, you can see that as I'm slowly moving through traffic in some areas, the VOC index was higher, likely due to exhaust from other cars. If you look at temperature, we'll notice some interesting patterns there. Where the temperature stays relatively constant, there are a few points where it drops a tiny bit, but this again is likely due to some climate control in the car. And we can test this under more extreme conditions if we were just to expose this directly to the environment. And so I will do some testing around different parks to see how maybe temperature and VOCs are impacted, if a park has covering versus not, or has real grass versus some turf or that rubberized mat. And then lastly, let's look at my humidity percent. And again, it looks like we have a pretty reliable measurement throughout our drive around town, where the lowest points seem to be around 12% and the higher points seem to be around maybe the mid 20s, the upper 20s. And so this is just a good way to test out if this little device works. This is my first time really trying to put all these pieces together. So I will do a walkthrough on the tutorial channel, more about how I built these scripts to do this analysis. It seems like it worked pretty well as I put these different pieces together on the board. Then of course, I had to put these different pieces together in the digital space as well. However, when it comes to this experiment, I would call this very successful. And now let me know what you would like me to do. I plan to map stores. I plan to go to different parks. I am planning to take a drive to Vegas and track that as well. I'm also curious to see what else you think might be interesting to measure, such as sound, visible light, or other things that could tell us about the world around us. In any case, I'll see you in the next video. Peace.